Sounds good. Sound is not coming through to YouTube. Yeah.
You know what? Yeah, my microphone's definitely not coming through. And let's see. Would you mind saying something real quick, Gregorius?
Sure. I'm saying something right now.
All right, that's definitely going through to YouTube. I can see that on the audio peak there. But yeah, it looks like I didn't have my microphone selected. All right, so let me redo my intro again. Hello, everyone. Thanks for joining us in the Akka.net stream. My name is Aaron Standard. I'm the maintainer of Akka.net. I've got with me Gregorius, Soed Harmo, who works here at Petabridge, and Iman from the Game Plumbing Framework. We have open source production values on both our software and on our stream, apparently. So we're going to go ahead and cover a number of things today. I went ahead and put together our agenda. In fact, you know what? Just so I can make sure everyone on the call can see what I'm sharing, I'm going to go ahead and share my screen real fast. So we are actually essentially going to be covering a little bit of discussion on the Akka.Persistence.Linq2Db project. We just released their first sort of stable NuGet package. Yeah, I think yesterday we did it. We're going to talk a bit about ongoing work on Akka.NET 1.422. We're going to talk a bit about some Akka 2.0 and also 1.5 futures, so a couple of future-facing concerns. And then we're going to talk about some community updates. Primarily, we're going to have Iman go ahead and demo his framework. And I'm going to talk real briefly about our Akka.Cluster Simply Explained webinar we did last week. However, before I dive into all that, I want to go ahead and add one little bit of recent news impacting the Akka.net community, which I was really saddened to hear this morning, which is that Latando, who is the creator of the architecture framework, a really popular CQRS and event sourcing framework, all built on top of Akka.net, Latando passed away at age 31 this morning. He had been tweeting the past couple of days about heart problems, and so he had been hospitalized, I think maybe since early July, late June. And he died at age 31 this morning. Really sorry to hear that. He's one of the people who I think has contributed a ton to the Akka.net community. And it's a really tremendous loss. I've always been a big fan of his architecture framework, and it's just a shame to go ahead and lose someone so young. So our thoughts go out to Latando and his friends and family and his colleagues, and we hope that we obviously hope that he's in a better place. That being said, his framework architecture is right here. This is a fantastic tool for being able to go ahead and build sort of domain-driven and event-sourced architectures on top of Akka.net. And he still put together a lot of really detailed documentation and walkthroughs like this project as well, which I'm going to go ahead and drop a link to. So I know there's still a very active community of users all around architecture, so they're probably going to need to there's probably going to need to be a process of having some new people step in to help run some of these repositories going forward. I have no idea what any of that's going to look like, since this is a project that exists entirely outside of Akka.net, but I know there's a large community of users who really want to maintain and use this framework going forward. So Hopefully, we'll have an update maybe in the next few months on that. But in the meantime, it's just a really terrible thing to lose a member of the Akka.net community and really just a brilliant young software developer who's contributed and done so much. So that's a tremendous shame. Now, moving on to the topics that seem much more mundane by comparison, I wanted to go ahead and talk a bit about Akka.Persistence.Linq2Db. And I'm going to go ahead and open up a separate GitHub issue discussion right here. And I'll go ahead and drop a link to this in chat. So Akka.Persistence.Linq2Db is meant to be a drop-in replacement for all of the basically sort of the relational database Akka.Persistence plugins. It's built on top of the Linq2Db micro ORM, and it is meant to follow very closely the JDBC plugins that the original JVM Akka project pioneered. So these are meant to be really high performance. They're meant to basically use all the exact same storage mechanisms that the current Akka.Persistence.SQL plugins use. So you can think Postgres, Oracle, SQL Server, SQLite. There's an Akka.Persistence.Linq2Db flavor for all of them built into here. And so one of the big benefits of using Linq2Db is it has tremendously improved performance, particularly for bulk writes over the traditional Akka.Persistence plugin models. So it's much more efficiently architected. It's used by Andrew, this is him here, very heavily at his company, which is a very large Akka.net user. And so this is all engineered for speed. He's in the process right here of trying to go ahead and collect some feedback from users who want to migrate from, let's say, Akka.Persistence SQL Server to Akka.Persistence.SQL linked to Akka.Persistence.Linq2Db.SQL. Wow, sorry, that's a mouthful. If I go ahead and go over here to the Akka.Persistence.Linq2Db repository, and I'll drop a link to this in chat as well, you can go ahead and see this new release we just did a couple days ago, which also has access to the NuGet package. This is also available, by the way, on NuGet.org, of course. So all this information should be available up there. And you can see the pertinent details on both performance, compatibility, configuration, and everything else inside the very detailed README in this project. So this project has now gone from being, let's say, somewhat of an experiment to being a stable released repository where we're going to begin honoring backwards compatibility constraints, API designs, and all the sort of usual stuff you'd expect to have in a mature project that's being delivered by the Akka.net team. So we're looking for more users who are using, let's say, Akka.Persistence really heavily, particularly around relational databases, to take this plugin out for a spin. Let us know how well it works. Let us know if there's any migration problems. If you used Akka.Persistence.SQL Server and migrated over to this, we'd be really interested to hear how your experience went and what we can do to try to make it even better. So that's one thing I wanted to go ahead and address. Next, I wanted to talk real briefly about Akka.net 1.422. So Akka.net 1.421, which came out, I think, around the time of our last community stand-up in June. Let me go ahead and pull up our releases here. Yeah, 21 days ago, was a major release that introduced all sorts of tremendous performance improvements and fixes over previous versions of Akka.net. And we owe a lot of those performance improvements to just getting more efficient about how we do things like parse actor paths and addresses and all that sort of stuff. The current milestone that we're working on right now is Akka.net 1.422. And most of what we've worked on so far for this issue have been fixing a number of logging and basically context capture messages. So we've been trying to do a more thorough job of providing clear and detailed sort of error messages around what happens when a message can't be deserialized. We're introducing clear exceptions around things like binding exceptions when that occurs. And we're also fixing a couple of long-standing issues with the test kit, such as last night, we just merged in a pull request where an actor of his test actor inside the test kit couldn't perform an await operation without losing its internal context. We've since fixed a lot of those. So this next release is largely slated to be a bit of a maintenance release, where mostly we're working on trying to fix long-standing issues with Akka.net's, let's say, usability or user experience. We have a couple of other big issues around things like distributed data that we're working on right now, like trying to make the Akka.distributed data system a little bit more robust, and working on fixing a couple of other smaller issues kind of around the edges of Akka.cluster sharding, DData, and a number of other different little problem areas. There's also probably going to be some Hyperion bugs that get fixed as part of this release as well, particularly around dealing with things like user-defined structs and that type of stuff. But I also wanted to go ahead and very briefly address some of the more future-facing work that we're beginning to consider for Akka.NET 2.0 and Akka.NET 1.5. So we periodically will go ahead and add things to some of these milestones that are a bit further out. So for instance, if I go ahead and take a look at our Akka.NET 1.5 milestone and we see what's open, a lot of this stuff has to do with replacing classic remoting with Artery, which is still a project that's being worked on. But today I just went ahead and added this issue, which is a proposal for actually introducing structured logging directly into the Akka.NET framework itself. This is all being done with the goal of trying to go ahead and make it easier to pass in context that's happening inside an actor while it's processing a message, and allow that to be exposed to an underlying logging system in a more, let's say, type-safe and somewhat native way, kind of similar to what Serialog does behind the scenes. So this is something else that I just proposed this morning. This was largely in response, funnily enough, to some issues we kept running into with Phobos, where certain diagnostic platforms, such as Datadog, for instance, require you to actually go ahead and inject into your logs all of your tracing and telemetry information in order for those logs and traces to be correlated, which is kind of unusual. Most platforms don't require you to do that. But that being said, it's a common enough requirement where we figured we should probably find a first-party way to make this a bit easier. The last thing I wanted to discuss for Akka.NET 2.0, as far as future-facing stuff goes, is that and I think I mentioned this when we did our roadmap meeting at the end of 2020, which is one big issue that we're looking at making significant changes to, is re-architecting the way actors fundamentally process messages. Now, this wouldn't really, I don't believe, have much of an impact on most of the code that you've written your actors around. But what this would change is basically how actors get scheduled and how they actually run the processing loop behind the scenes. Back when we were first trying to get Akka.NET out of beta and into a stable release, this is like in 2015, trying to use async await and tasks inside the actor messaging processing pipeline was extremely non-performant. Basically, it's a difference between processing tens of millions of messages per second versus processing like maybe a few, like maybe processing 500,000. So it was a several order of magnitude drop. And that had to do with all of the different, let's say, units of work that had to be allocated behind the scenes, and all the garbage collection that resulted in, and a lot of other, let's say, this generally speaking, inefficiency that would appear inside the Akka.NET message processing pipeline. Well, now that the .NET language has evolved quite a bit since 2015, not the .NET language, excuse me, that the .NET, let's say, constructs for being able to do concurrent programming have evolved quite a bit. We have tools like value task, for instance. We have the ability to go ahead and write an iThreadPool work item that can be scheduled directly on the thread pool without needing to allocate any delegates or anything like that. We also have the ability to go ahead and provide basically new zero copy structures that can go ahead and eliminate a lot of closures and things like that that occur inside some of the way actors program and build their behavior. So we think there's some opportunities that we've identified for being able to rewrite the internals of the Akka.NET dispatching system to essentially make it so every time an actor processes a message, it's doing essentially a tail recursive task. It's essentially always awaiting. And when an actor is sitting there with no message inside its mailbox, it's actually producing a little await state machine behind the scenes. Now, obviously, before we would go about actually exposing something like this to end users, we would need to carefully performance test it, We would need to have a migration guide or preferably a Roslyn analyzer that could go ahead and just move all of your old code to the new code format. And that's why this is being considered for Akka.NET 2.0, which is something you can expect to come out like next year. It's not going to be a 2021 issue. But this is some of the stuff that we're beginning to kind of outline and discuss. We're trying to capture some of these requirements down on paper now. So that's sort of where we're at with some of the current sprint around Akka.NET 1.422 and some of the work being considered for Akka.NET 1.5 and 2.0. Okay. Let's see. Gregorius, did I leave anything important out that we should discuss?
No, I think that's about it.
All right. Well, I'll take. Yeah. All right. We'll go ahead in that case then. Iman, the floor is yours. Let's go ahead and take a look at that game plumbing framework.
Thank you so much. Let me just get this.
And I'll go ahead and make everything, let's see, full screen here.
Okay. Does everybody see the slide?
Yes, I see it.
Okay, wonderful. My name is Iman Kabazian, and I have a passion for building games. I'm a former technical director at Disney, and I've built games that drove over $80 million in revenue. And today I'm here to tell you about a game framework that me and my good friend and colleague, Dan Parker, built with Akka.NET and inspired by Akka.NET, really. And it's called Game Plumbing Framework, or GPF. Today I'm going to share what we built, describe the architecture, and talk about exactly how GPF accelerates development velocity for Unity developers building a game in Unity. To understand the problem GPF solves, we have to put ourselves in a Unity game developer's shoes. Unity game developers want to create fun games, and these games need a safe player state. They're often multiplayer, so they need backends, but building these backends can often be anything but fun, because if you hire a backend programmer, they're usually pretty rare, hard to find, pretty expensive. I'm sure we have some expensive backend programmers on this call. You have to build for scalability, and this is something a lot of people struggle with. Fortunately, Akka.NET helps with that. It's been my experience that game logic usually has to be scattered throughout the stack, or ends up scattered throughout the stack, because you have to put game logic on the front end so your game is responsive, but then you have to put it on the back end so your game is authoritative server, so people can't cheat, and it ends up kind of reflecting itself in the networking layer as well as in the database layer sometimes. And on top of all of these obstacles, today's games are much more complicated because users are demanding multiplayer everything. So you got to keep everything synced up. So the way Game Plumbing Framework solves these problems is we try to abstract away the complexities for Unity developers. So we empower them to easily customize backends and integrate with their data. So this is kind of the only solution where a Unity developer is going to build something, and it's going to do two things at once. One, it's going to serve as game logic for the client, and two, it's going to be deployed to the back end and serve as game logic on the back end. So within the development environment they're used to, they're actually creating and deploying back-end logic kind of behind the scenes. We also provide tightly integrated systems that let them take the data that is kind of buried within these back-end abstractions and make it really easy to hook that data up to UI. So to help further explain the origins of the framework and the value it brings, I will take you back to the events that kind of triggered the creation of Game Plumbing Framework. Back in 2019, I was hired to architect a massively multiplayer map system for a Unity game. And that team wanted a backend that ran in C# because Unity runs off of C sharp, and they wanted their developers to go full stack. And this is kind of a goal that I've always thought would be really helpful, but few teams have been able to really pull it off. So I was looking for, first I started looking at stateless backends, because scaling stateless backends was kind of my specialty. But it became clear that because of the connected nature, it would be super expensive to scale a stateless backend. So that's when I found Akka.net, and it was just the perfect solution. I did the boot camps, I read the ebook, I recommended it to the team, and I was really inspired by how thoughtful the code base was and how it solved some really hard problems and kind of put us in a position to win this battle in a way that scales, and in a way where we're not painting ourselves into a corner. And I watched the team work with it. And at first, they seemed happy because the MMO problem was like this impossible to solve problem. And now they had a path. But at the same time, I saw them struggle with, their whole goal was to share code on the front end and the back end. And they, when a backend engineer got in there and ran his tests and changed that code up, he would break the front end engineer. And when the front end engineer would try to get into that shared piece of code, he'd break the back end engineer. And they just couldn't figure out exactly how to separate this code and how to still leverage going full stack on C sharp. They also struggled building a networking layer. So kind of inspired by the Akka.net project and walking away from this project and seeing their struggles, I wanted to build something that would solve those problems. And my vision was, well, what if Unity engineers could create actors with game logic from the Unity environment, and then use that actor both in Unity and deploy to, let's say, an Akka.net backend. And then I kind of refined that idea and came up with this thing I call server objects. And they look a lot like actors. They're reactive, but Unity engineers build them, on the front end, and our framework will go one, it deploys it to the back end, and two, it keeps that front end version in sync. So we handle all of the networking, and I was really happy with this project, but um, I wasn't quite sure how we would integrate it with Unity, because my integration path seemed kind of dirty and overly technical, and I wasn't a like hardcore Unity engineer. So I called the best Unity engineer I've ever worked with, a guy named Dan Parker, and I showed him what I've been building, and I kind of asked him his thoughts. Well, it turned out he was working on a reactive UI system for Unity, one where he has this data store and this UI layer. And when something, you put all of your information in the data store, and when information changes, it automatically updates in the UI layer. And it's super simple to hook up UI to your data store. And I said, well, if we combine our projects, that might be something pretty special, because I could take the server data that's being changed, and we could just funnel it into your data store. And then that, the reactive chain will go all the way up to the UI. So basically a fully reactive stack, front to back. And, we were super psyched. We decided to coordinate, and eventually we merged our projects, and we really built out this server object ecosystem. And as you will see, we took it pretty far. So here's a component diagram of what we ended up building. Um, we have we have server objects where we've created that base server object class, but the developers can go and extend that. And when they do, they automatically inherit persistence and the ability to message and the ability to kind of sync to one of those objects. And it just automatically flows into their client. And we have this piece called Syncer, and his whole job is to keep everything in sync. And he automatically updates the data store. That's that part that Dan started working on when we started working together. And that data store will automatically update everything at the UI UX layer. So let's look through some code. This is an example of a server object. And the first three lines are we're giving the server object a path in the data store with an attribute. We're saying it's syncable, so some server objects can get synced to the client and some are just supposed to be out there in the cloud. And we're giving it a name. In this case it's hello. um, and then the server object has some state. In this case it's the greeting, what's your name? And then it has something that might look familiar, which is a handler. So here's a handler that takes a custom message. So this is completely inspired by an actor. And you'll notice that just like actors, we're going to use the name handler for every single handler, and the difference is the type of that message. And we can handle messages basically two ways. We can change our state, anything on our state, or we can send a message to another actor. So the advantages here are now Unity engineers are actually building uh, server logic without using backend engineers, and they're allowed to run this and test it within Unity. And then once it's all working, that thing greeting is going to automatically pop into their data store and stay in sync. And so all of the UI that uses that is going to automatically stay in sync. So we can look at the other thing we did is we made this stuff very easy to test. So one thing Unity developers really struggle with is writing test code because everything is so visual. But we came in and we said, no, there's this strict separation between visual and state. And there's a feature in Unity called Test Runner where you can run unit tests. Most Unity developers I talk to have never even seen this feature. It's like you go window general test runner, but they don't know it's there because it's just not a part of the culture, because state and UI are generally mixed together. But with Game Plumbing Framework, there's a complete separation. So now we can test everything that's going on. So in this test, we're basically creating a syncer. So we need a syncer in order to sync stuff. And we're creating an ID. Every server object has an ID. And then we sync to it. And then we send it a message. And we can do an instant send, or we can do a send wait, which means that line of code doesn't return until the server object has received and processed the message. And send wait is really helpful for testing. And then we can just use like asserts, to make sure that that all worked. Another thing we do is we make debugging super easy. So what you're looking at now is a auto-generated diagram. So let's say we created this for a game. This is one of our demo games where you can flip a coin and we have a leaderboard. So we auto-generate these diagrams that show you what's messaging what. So in this case, the client messages the coin player server object, and that messages the coin leaderboard server object. So when you have a bug, you can first you got to figure out whether it's on the server object layer or the UI layer. And you can look at our data store explorer to see all of the data that's in the data store. And if that data looks like there's something wrong with it, well, then the issue is in the server object layer. So now you can go and look at your test, you can auto-generate this diagram, and you can figure out exactly what's going wrong instead of like looking through log files. The other thing we were able to do is we took our server and we created a client version of that within Unity. So you could right click and run these tests in simulated mode as opposed to in client server mode. And that lets you put a breakpoint inside your server object, and you can like hit it from Unity and you get your full stack. Or you can, let's say you're playing your game and you hit a breakpoint and now you have the full stack all the way up to the what happened at the UI layer. So full stack debugging is something that happens when you take your backend and create a mock version and bring it into the the toolkit. We've also streamlined just the ability to add UI, right, or to bind UI to data. So I talked a little bit about our data store, but we also have this. We've created all of these UI. Um, uh, uh, UI elements, components that you can actually go in, and through the inspector panel, you can basically look up everything that's in your data store. So we have global state, but we also have like an autocomplete lookup mechanism. So we've shifted a lot that used to be developers writing code to glue state to UI, and we've shifted it into like these inspectable, easy to find, this hierarchical uh, view components where they can really quickly take that server state and visualize it. And game plumbing framework keeps everything in sync. So those are just some ways that we've been able to really accelerate the development process. um, and right now we have two available backends. We have the enterprise Akka one, which is far more interesting, but we also have the AWS serverless one. And we have a serverless one because that lets people get up and running and go client server basically within 10 minutes of downloading our software. But the enterprise one, we've tested it, and it's just like way easier to, way more affordable to scale, and your latency is going to be just far less, right? So we've, if you think about what is your latency for a message to the server and write back, with AWS serverless, it's 40 milliseconds plus ping. But with our enterprise Akka.net server, it's just ping plus 5 milliseconds. So way faster, but it's even more impressive when you think about hops, like one server object or actor messaging another, because with AWS serverless, we pay that 40 milliseconds for every hop. And with our Akka, enterprise solution, we didn't actually see any significant like extra time for the hops. That might be limited testing, but that's kind of what we have observed so far. So I kind of started this out thinking, wow, Akka.net, this is such an amazing project. It could be very useful for game developers. Why isn't everybody using it? Then I kind of saw why people weren't using it. And that basically took me on a 2+ year journey to try to create something where Unity game developers will be able to harness this power, because I really believe in this architecture and writing reactive code.
And
So yeah,
just to recap, the reason why they weren't using it was because the leap from doing stuff in Unity to doing things on the server with Akka.net required you to basically go ahead and connect all the dots together.
yeah,
Whereas you've basically shortened that journey down to something that's a lot more turnkey. Um, and basically kind of also offers things like observability and debuggability and UI integration as kind of like somewhat solved problems rather than blank sheets of paper that you have to fill in yourself.
absolutely. Yeah, we just noticed that as we put things in a framework, and we had this idea of a server object, we could take it much further. But yeah, that was the point, is to kind of connect those dots for people.
Well, that's fantastic. And I that point you make about the latency overhead of the serverless version, like its own internal communication with all these objects interacting with each other. Like
Yeah,
if you imagine, let's say, chat room object, you have one chat room object, a message gets posted to there, but then that also has to get posted to, let's say, the message state for each individual user who's subscribed to that, who might be running on all those clients. And just the internal dispatch overhead of all that decision making on the server has measurable latency with serverless. Whereas with
yeah,
Akka.net, all that messaging might be happening in memory, in which
yep,
case it's like it's we're talking microsecond level latency there.
yeah.
So yeah, so that's really cool. I appreciate that.
My pleasure. Yeah, I let me stop sharing, and I have a link to our like we have that coin flipper game that I kind of referred to, so I
Yeah.
could put a link to that if anybody wants to um, check that out. But basically, you're flipping a coin and you're hitting a leaderboard, and I'm happy to kind of uh, go through the code for that as well, or answer any questions. Or even auto generate the diagram like real time, whatever you're interested in.
Well, you know what I'm going to do? I'm going to go ahead and take over here for a second. And I'm going to go, actually, I'll share my screen again just so you can see. Go ahead and do that. Everyone who's already watching on YouTube can see my screen, but I'm going to go ahead and play Coin Flipper. All right. So I'm here. I'm going to go ahead and change my name here on the web. All right. I'm going to flip a coin. Let's see. Do I need to hit enter or anything to change my name?
I think
Oh, there it
you just
goes.
click out.
Yeah, I just saw an update there. All right. Well, I've got someone beating me right now. All right. Longest streak. My current streak is 1. My current streak is 0. All right, now I'm at 2. Let's see if I can get up to 3. All right, there we go. Let's take that.
Nice.
Now I'm at 4. All right. There we
You're
go.
good.
Okay. Now I'm back to 0 again. All right. Well, this is cool. So these are all some. So is this using the serverless version behind the scenes?
Yes.
Okay,
Right now we're
cool.
using the serverless. Yeah.
That's
We
very
haven't got
cool.
our cluster up yet.
Well, it goes to show you the value of having, let's say, like having built in, let's say, event sourcing and persistence, and the ability to go ahead and essentially have a state object you can canonically refer to, just like an actor, right? That's very cool. All right, I'll go ahead and stop sharing my screen there. All right, well, Iman, you're going to go ahead and include some, give me some YouTube links I can go ahead and embed in the show notes for this video. We'll go ahead and refer to them at the end as well.
Okay.
I really appreciate your demo, and if people want to find out more about Game Plumbing Framework or use it for their own Unity applications, where should they go to go ahead and get that info?
Gameplumbers.com. So I'll stick that right here.
All right.
And if you
Yeah,
go to
I'm sharing your homepage on screen here, so gameplumbers.com. I'll go ahead and drop a link to this in chat as well. All right. Sorry, I didn't mean to interrupt you. Please finish.
No. We also have docs.gameplumbers.com, and that has 3 of these demos, just like Coin Flipper. It has, so you can play them. We have YouTube videos on basically every section in the page, so fully documented, also with YouTube videos.
Well, great. Well, thank you very much. It's always really fun to be able to go ahead and on our community stand-ups demo someone else's work on top of Akka.net. And we really hope that you're totally successful with Game Plumbing Framework. And I'm definitely going to go ahead and take another stab at this coin flip game too when I get the chance here. I'm jealous. I wish I knew how to program in Unity. Gregorius on our team knows how to do it. But not me. I'm just I'm a simple backend developer. Well, Iman, thank you very much for your time today. I really appreciate it. And to everyone who stuck with us on the call today, we appreciate your time as well. Thank you very much for being part of the Akka.net community. And we will catch you all next month at our August community stand-up, which we'll go ahead and probably get scheduled a little bit earlier next time. All right. Thank you very much, everybody. Bye-bye.